back to Muddy Math, where we take middle school math concepts that are a little muddy and clear them up. Today we'll be finding the missing part to a whole using a percent. The focus is on proportions and solving one-step equations. Stephen Curry had 810 three-point attempts during the 2018-2019 season. He made 43.7% of his attempts. Steph averaged 11.7 three-point attempts per game. There were 69 games in the season that he played in. How many baskets did he make per game on average and in the season? To solve this problem, first we want to organize our information. We want to know how many three-point attempts did he make per game and in the season. So what information do we need here? We need his total number of three-point attempts. That's the whole. There's another whole in this problem being the average number of attempts per game. We need to know the percent of the attempts that he actually made. Remember, 43.7% can be rewritten as a ratio or a decimal. We want to know the missing part. How many did he make? To find how many three-point attempts he made in the whole season, we can ask this question. What is 43.7% of 810? To find how many three-point attempts he made on average per game, we can ask this question. What is 43.7% of 11 7/10? Is associated with the part, of is associated with the whole. You will always know that the percent is corresponding to the part, and the 100, which is what the percent is out of, corresponds to the whole. We're going to solve for a part in two different ways, keeping the percent as a fraction and keeping the percent as a decimal. When we solve for a missing part using a proportion, you convert the percent into a fraction form. The percent corresponds to the part, and the 100 corresponds to the whole. Just like a percent is out of 100, part is out of the whole. When you solve for a part using an equation like this, you multiply the whole by the percent as a decimal to find the part. We do not know how many three-point attempts he makes, so we use a variable, a. We know he took 810 three-point attempts. We know he made 43.7 out of 100 field goal attempts because our percent tells us 43.7% is out of 100. Viewing this proportion as a one-step equation is the most straightforward way of solving it. So I'm going to ask myself, what is happening to the variable? The variable is being divided by 810. To isolate the variable, I need to multiply, which is the opposite or the inverse of dividing, multiply both sides by 810. What I do to one side of an equation, I have to do to the other. When solving for a variable, it might be helpful to draw a line down through the equal signs as a reminder, what you do to one side, you have to do to the other. So now I can simplify. 810 divided by 810 is 1. On the right-hand side, I need to ask myself, what is 810 times 43.7? We get 35,397, then we divide by 100. We can check our answer by resubstituting the value for a back into the original equation. 353 and 97 hundredths divided by 810 equals 437 thousandths, which is the decimal form of 43.7%. We solved for the part properly. Now for another method. What is 43.7% of 11.7? Let's substitute our values into the formula. All we need to do is find the product of 437 thousandths and 11 7/10. The product of 437 thousandths and 11 7/10 is 5 and 1,129 10,000ths. So on average, Steph Curry made about 5 three-point attempts per game, and in the whole season, he made 354 three-point attempts. In both of these cases, we round our final answers because the percent given to us on NBA.com was rounded. Steph Curry made 354 out of his 810 three-point attempts. This is approximately equal to 43.7 out of 100. Using the same logic, we can say that Steph Curry made about 5 of his three-point shots per game in this season. Thank you for tuning in. I hope you enjoyed learning about proportions and equations to find a part when given a whole and a percent. Please hit that subscribe button. Don't forget to like the video. And tune in next time for more middle school math concepts that get cleared up because they're a little muddy.